Welcome back, everyone. What a fascinating day we have had so far on our Space Symposium. Let's introduce our next company. We have Momentus, Inc. It trades on the NASDAQ under the symbol MNTS and is a leading U.S. provider of in-space infrastructure, transportation, and bus services, including hosted payloads and in-orbit services. With me here today is Chairman and CEO of Momentus, John Rood. Nice to see you, John.
It's great to be with you. Thanks for having me on.
All right, so give us an overview of Momentus and what specifically the company does.
We're an early stage space company based in Silicon Valley, California. And what we do is we make a satellite that delivers other satellites to custom, precise orbits for in-space transportation. We do servicing of other satellites. Think the services we intend to offer, things like refueling, repositioning, repair. And then we also provide a very good satellite bus capability for national security missions that we're bidding with the Defense Department, as well as for commercial customers, things like commercial navigation services, Internet of Things connectivity. And so we're filling a niche that didn't used to exist before because of the lower launch costs and the smaller size of satellites that need to be repositioned, that need to be placed in precise custom orbits, kind of like the UPS of space here.
The UPS of space, that makes a lot of sense. So for those of us who aren't familiar with the company, give us a history of the company. How was it founded? And an overview of some major milestones thus far.
The company was founded in 2017 as a startup, of course. And then we went public on the NASDAQ about 2 years ago. We went through some ownership changes, but then once we hit our stride and went public 2 years ago, we've really made steady progress towards our goal of providing these kinds of services. And so some of the key milestones, we did our first launch last May of 2022. And since that time, we've launched 2 additional spacecraft. So we've put 3 into orbit in under a year, which is very fast in the space industry. And we've also now deployed a number of customer satellites. We're hosting payloads for companies like NASA as well as Caltech, and really seeing a growth in interest in our capabilities because, as I say, there are a couple mega trends. The cost per kilogram to send something to orbit has come down dramatically. You know, McKinsey says it's come down 95% over the last 20 years. So that used to be a huge barrier to entry for companies and small satellites to want to go to orbit. And then the other thing is the capability you can pack into a very small satellite. Think things the size of tennis ball cans, the size of hockey pucks, the size of small microwave ovens is very large. And so those 2 trends are creating a demand for new services where you have more availability for rockets to take things to space. But then that cargo, if you will, needs to be transported to the correct orbits, to where these precise orbits need to be. Or when we're supporting national security missions, there's a lot of unique needs that our Space Force wants to have in the United States for dynamic space operations, to operate with maneuver. Think very similarly how aircraft operate in the U.S. Air Force in the air or the Navy operates on the sea.
So that's where the UPS of space comes in for with your company. Before we get more into specifics of that, John, tell us a little bit about your leadership team and some of the background highlights.
We have a very strong leadership team that we're proud of. That this will sound immodest, but I think for a company of our vintage and class, we have the strongest space leadership team in the industry. And the reason is that we've recruited a number of very strong leaders who, like Tom Malco, for example, our Senior Vice President for Engineering and Operations. He formerly led Space Systems Company for Lockheed Martin's. He was their chief engineer and their head of operations for many years, a 38-year veteran. We have another person that's our vice president for special programs. He was, for 25 years, he led the Lockheed Martin Skunk Works Revolutionary Technologies Directorate. So bringing new technologies to life there that are populating the skies. And then we have a whole series of others with commercial backgrounds, like our Chief Technology Officer, Rob Schwartz, who has a 25-year history at companies like Maxar and Space Systems L'Oreal, where he was the Chief Systems Architect or CTO at those locations. And then we've recruited a whole bunch of others that populate that, from a very strong CFO with experience in technology companies and raising capital for early stage companies, Eric Williams, and a variety of others. And we have this unique hybrid culture where we have lots of young engineers that are eager to change the world and do things totally differently. And then we have some veterans that have all the scars to prove what does it take to be successful in space. And there's a nice tension between those cultures that has produced, I think, a very strong hybrid culture at Momentus that allows us to be innovative, to go fast, but to still have very strong performance in orbit and to adhere to best practices.
And let's talk product. What does Momentus currently have operational in space? And what is your timeline for future launches? Are they on track?
Yes, we have currently 3 spacecraft in orbit, 2 of which we're controlling at the same time. Again, our first launch was in May of last year, and then we did one in January of 2023, another one in April of 2023. So the last 2, we're concurrently operating them in space from our operations center in San Jose, California. From those satellites, we have deployed other smaller satellites, playing the role, if you will, of the UPS truck that picked up the cargo in one location and took it to the precise orbit to deliver it to your house or your business or what have you. So we have deployed other satellites in that fashion, and we are also supporting a big hosted payload, meaning we provide power and communications and other support to it from Caltech. That's really a very interesting, groundbreaking system that has shown the ability to collect solar energy in space and wirelessly transmit the electricity to Earth. They've demonstrated this to send some to Pasadena. It's kind of like, you know, Bluetooth transmission of electricity, if you will, that they're trying to demonstrate. So we have 3 spacecraft, 2 of which we're operating in space. The next launch will be in October of this year, of our next launch, called Vigoride 7. And it's an orbital service vehicle. Think of it like a utility vehicle in space or a small delivery truck that can both deliver things, host payloads, and provide support to them, but also support national security missions where we're seeing a lot of growth and interest in our capabilities. So that next launch in October, we'll do a couple of interesting things there. One, we will do what's called remote proximity operations. We'll release a satellite, and then we'll show the ability to maneuver up very close to it, within 2 meters, to back away, to reposition ourselves, and so on, because we want to eventually have the ability to refuel satellites and service them. Most satellites today just run out of fuel at the end of their life. It's kind of like leaving your car on the side of the road instead of refueling it. So we will have the ability eventually with our roadmap, technology roadmap development, to do that. The other thing we're doing is we provide a satellite bus for communication satellites, for navigation satellites, and other things that instruments are loaded on, payloads, to support those missions. And we're seeing real interest from the Defense Department and elsewhere in that capability.
Fascinating stuff.
In the future, we have some new products that will come online. One that is in orbit today that we will demonstrate is a rollout solar array called tape spring solar array. Basically, you know, if you went to Home Depot and you bought a measuring tape that you can roll out and roll back in, that's metal and has a concave shape, that's the method we're going to use, where we've laid down solar cells on a similar metallic structure. And it's 11 meters long, the booms, and we'll unfurl that. And the benefit is very low cost. It's rolled up in a mandrel, kind of like a giant roll of a Reynolds wrap aluminum foil that you can roll out like a tape measure and roll back in when you need to. And our goal is to generate per watt power at 50% of the cost of the leading solar arrays on the market. So we'll demonstrate that here in about 2 months. And then we have further things on our drawing board, but right now we're really focused on growing into the national security missions with some bids that we're planning to submit for things to support the Space Development Agency for communications and tracking and missions like that.
Fascinating. It's also visual. You know, you can actually see it with the way you describe it. So talk a little bit about how does Momentus's track record of flight heritage stack up against the competition? And you mentioned improved efficiency and successful missions with each successive launch.
We've done 3 launches in under a year, which again is very fast. We're already flying in space. Some of our competitors are also flying, but there's a whole pack of them behind us that has yet to fly in space. And to be sure, space is a very unforgiving, harsh environment. So the exacting standards required to be successful there take time to develop. And anybody with a history in the space industry has got scars to prove that as much as you've done things, not everything will work out perfectly the first time or the second time. So we've learned an awful lot from our missions, which we're very proud of the success that we've shown. And our core technologies are all now shown to operate in space. We've demonstrated them. For example, we've got a groundbreaking propulsion system that we've operated and shown it can perform all of its near-term use cases in space. And we're very pleased with the results we're seeing. So some companies, like we have a competitor, Impulse Space, as an example, they haven't flown yet. They're planning to try to fly their first mission later this year. We would consider ourselves ahead by quite a bit in having more flight heritage there. In other cases, that we do have some foreign competitors that have flown and flown successfully. There, we've got to compete on other differentiators: higher power, more flexibility of our payload, the ability to handle different sized payloads, and of course, always the standard things: service and price and responsiveness to your customers.
So talk a little bit about Momentus's proprietary microwave electrothermal thruster, easier put, MET, and why it's so groundbreaking.
This is a groundbreaking system, and Momentus is a pioneer in commercializing it. There have been university studies on using water as a propellant with a microwave source to heat the water to create a plasma and produce thrust for, I don't know, 20, 30 years. But we took that and are in the process of commercializing it. And the way it works is we have distilled water, just ordinary water that we carry on board as our propellant. We create a vapor and apply microwave energy to it, very similar to your microwave oven, but just at an industrial scale, and heat that vapor to about half the temperature of the sun. That's the easy part. The hard part is the resulting plasma controlling it. And so we do, and create a thrust effect from that through a vortex. And that plasma produces very good thrust. So when measured in specific impulse, which is similar to the fuel economy in your car, like miles per gallon, this is measuring thrust per unit of propellant. We can be more efficient than chemical propellants, which are highly toxic and hard to use. And so we've demonstrated the operation of this thruster in space on our Vigoride 5 spacecraft. We've shown the ability to maneuver the spacecraft to a higher altitude and change its location. And for the use cases we see that we're going to use this for in the next couple of years, we've now demonstrated it in space. Where water is valuable is, again, it's more efficient. We can provide higher specific impulse than chemical. But secondly, it's easier to handle. It's environmentally friendly. It's not even under high pressure. And lastly, water's found in abundance on the moon, on asteroids, elsewhere. And so if you want to talk about supporting longer term missions, which we do aspire to support in and around the moon and beyond, the kind of chemical propellants that are in effect today won't allow you to support those missions. It'd be the equivalent of driving from California to New York with a giant fuel tank behind you to carry all the fuel you will need for your mission. I mean, that's not an effective way to do that.
No. Let's talk a little bit more about your technology, John. You're also developing innovative technology called Tape Spring Solar Array, remote proximity operations, and impact propulsion. So let's break down each one of those and the significance for Momentus and the industry in general.
The Tape Spring Solar Array, as I mentioned, is very similar to the measuring tape you'd find at Home Depot. And where we're trying to take advantage of cost reduction is weight equals cost in space. And so using the structure, the concave shape of this rollout array to support the solar cells, to drive down to a very low cost, flexible solar cell that doesn't necessarily produce the most electricity like some exquisite ones, but the per watt cost and how much it will cost to generate the required amount of power with this low cost deployment method, we think is very valuable. It's also helpful if you want to reposition your satellite and maneuver. You can roll the array back in, maneuver off to your new destination, which for national security missions can be very valuable. Or frankly, when you have large constellations, which are envisioned of thousands of small satellites, think of it like a communications node or a node of lights that you have some dead spots in. The ability to reposition yourself to fill those locations or to have a space truck like ours come and move you there is very valuable. So the Tape Spring Solar Array will demonstrate here later this summer. We're really excited about its potential, and it has other potential applications to serve for space structures and things for habitation and in-space manufacturing. So some companies commercially and in the government have talked to us about other applications of the technology, and we're in conversations with them to try to meet those needs. The other two technologies you mentioned there with remote proximity operations, what that will allow you to do is if you can maneuver up closely to other satellites to refuel them, you can extend their useful life very significantly. There are other things you can do for close inspection or for military applications, surveillance, reconnaissance, things of that nature, situational awareness of what's going on in space, or the application of effects if you wanted to. The other part that you can do with that is that dock with other objects to support in-space space stations and manufacturing. There are a number of private space station companies that are starting to do refueling, replenishment, resupply, things of that nature. But we're seeing, a lot of interest in this remote proximity operations capability, though, from the Defense Department for military missions. And I think there we will see some real growth in the future. So that is a noteworthy capability. Again, we will demonstrate that in October. And then the other application is deorbiting of satellites. Today, there's about 5,500 satellites in orbit. According to the Government Accounting Office, there will be 58,000 by the end of the decade. All of those objects there is a new rule that the FCC has put in place in low Earth orbit, below 2,000 kilometers. They have to be deorbited within 5 years of end of useful life. So that's going to create a large market opportunity for remote proximity operations to come and attach yourself, use a robotic arm like we're developing or other grapple fixture, and tug those satellites down so they can burn up upon reentry. And this is going to be a large market opportunity because the projected growth is really impressive, both in the size of the space economy and in the number of deorbiting requirements you're going to have. So we're planning to do that with remote proximity operations. The last thing you mentioned there, impact, is the ability to use the water that we have on board to do electrolysis, create hydrogen and oxygen, and create a propulsive effect to basically think of it like a afterburner to put more fuel into our thruster to improve its performance even more. Sometimes you see this with street racers or cars where you can dump additional fuel into the engine and provide a much higher throughput. And so impact would give us the ability to support very long duration missions. Think like the Space Force talked about a highway patrol to the other side of the moon and back, always patrolling the heavens and things like that. If you can make your own propellant and use it to add propulsive effect like we could do with electrolysis, that would be really attractive. Or for long duration missions like NASA might want to do to distant planets or asteroids, things of that nature.
Thank you for that breakdown of each of those technologies. Let's talk about your competition. What would you say is Momentus's competitive differentiation?
I think some of the competitive differentiation is our satellite bus, our orbital service vehicle, if you will, can carry more payload, more flexibly, and has more power available than the competition. And we're also very fast and low cost. But if you start with those, as compared to some smaller capabilities, we have the ability to carry up to 800 kilograms on our satellite when loaded in the what's called the top hat configuration. We can do 350 kilograms loaded on the side of a launch vehicle, which our competitors, many of them cannot carry that volume. We also have a very flexible configuration that others are unable to accommodate larger satellites or those with different shapes or some of the instruments, because we have a large flat deck that, think of it like a flatbed truck that's been optimized to carry many, many different things. And lastly, we've got substantially more power. From what we can tell, we are, a market leader in the amount of power we can do in our class. And in that area, power is kind of the coin of the realm in space. It defines how you can communicate, how many instruments you can use, what you can do with your spacecraft to take images, to manage your payloads on board. And so the fact that we've got substantially more power than others, we think gives us a real differentiator as well. And then again, the ability to be very responsive. We produced 3 spacecraft in under a year. We can take your requirement as a new satellite company and have your satellite in space in a year, which is very fast in the industry, and at very low cost. And so we think we stack up very well as compared to our competitors.
John, talk about who your customers are and what's the market like?
Our customers today are predominantly commercial, but we're really focusing a lot more on government customers to grow that. One of our government customers so far has been NASA, where we supported a mission of theirs to study the density of the atmosphere and essentially like space weather. But we have also been notified by the Defense Department, the Space Development Agency, of a contract award that we'll receive. And so we're planning to support the Space Development Agency, Space Force, a number of the intelligence agency missions going forward in our future. In the commercial side, some of the customers that we've signed include 4 Internet of Things companies. And so each of them want to put at least several hundred, or in some cases over 1,000 satellites in orbit in specific locations to provide Internet of Things connectivity. For those that aren't familiar with that, some examples, it was in the media this week, one of the chief technology officers at John Deere Tractor talking about using Internet of Things connectivity to autonomously operate their tractor fleets around the world. Think not the farmer getting up early and riding his tractor all day, but the tractor doing that autonomously. Or we all get Amazon packages or UPS things delivered to us, and we can tell where that package is. Internet of Things connectivity helps provide that tracking or connection between other communications devices and things of that nature. So we have 4 companies that have signed contracts with us to fly their initial satellites, and we're hoping it'll be the whole constellation later for these satellites. We support other commercial customers that are interested in similar effects, either to demonstrate their hardware in space or support imaging of various things. And then we have some academic institutions, like I mentioned, like Caltech, that we have a very large hosted payload to support this experiment to collect solar energy in space and wirelessly transmit it to Earth.
Wow. Let's talk about some trends in the industry right now. What are you seeing, and how are the long-term growth prospects for each market?
I think there's a real innovation curve that we're riding here, and the reason there's a need for that innovation is that these mega trends that I discussed earlier are occurring, where it is just the access to space is much more available, much easier to get there. That just used to be such a barrier to entry. And with more and more entrants into the launch business, that's going to get easier. And some of the very large vehicles, like the SpaceX Starship, today a Falcon 9 from SpaceX carries roughly 100 satellites in a rideshare mission, or 52 in a Starlink mission, for communications. Starship, by comparison, is going to do something like 500 of the equivalent satellites. So you're going to see this huge container ship, if you will, taking all these containers to space, very similarly to the ones that do so on the seas. All that cargo doesn't want to go to a single port. It wants to be delivered precisely throughout orbit. And so that will drive a need. Also in the national security area, the activities of countries like Russia and China, and our Space Force leaders and Defense Department leaders have talked about, they need a maneuverable, dynamic, responsive force. And so some of the older ways of doing business in space won't work for those type of missions. And that's where a utility vehicle like ours that can maneuver, that can reposition itself, that can support a full range of missions very flexibly with a lot of payload and a lot of power is very attractive. So I see those markets expanding. The overall market's growing. Space Foundation says in 2021, the space economy was $469 billion. Number of other estimators like Morgan Stanley estimated it'll be a $1 trillion market by 2040. So you're going to see substantial growth there. Within our segment, things like satellite buses, that's also seeing very substantial growth, and for the in-space transportation. So I think the trend for the market is very bright, and you're going to see more and more applications done from space that used to be done just on Earth, because it's to benefit things on Earth, to make the economy better, to make it more efficient.
Well, with all of these trends, let's talk milestones. So what milestones do you hope to achieve over the rest of this year?
We're tracking again in later this summer. First milestone is we'll continue to operate the 2 spacecraft that we have on orbit and put them through their paces and learn more about the spacecraft's performance beyond what we've already learned, which is very substantial. And we'll show our capabilities, showcase it, if you will, in space to maneuver and reposition ourselves in other activities. We're also going to do later this summer the initial deployments of our tape spring solar array and demonstrate that technology in space. This is the first mission we're using that, so that'll be a key milestone. In October of this year is our next launch, and we're going to carry a number of customer satellites to orbit, and in addition, perform this remote proximity operations demonstration that I described earlier. Next year, we've booked ports on 3 SpaceX launches, all of the rideshare missions SpaceX has, and we'll continue to fly customers and other satellites at that time. And we're going to continue to compete or begin competing even more aggressively, I should say, for a number of the solicitations the Defense Department and others are putting out. So those will be key milestones for us as well, to keep those competitions, hit those dates, and produce good results.
Fantastic. Well, let's end with some key takeaways that you want our investors and our viewers to have about Momentus. Some closing remarks from you, John.
Well, I think in our journey, we've come to the stage now where, like a lot of other early stage tech companies, we had ideas that existed on paper that we needed to raise money for and then develop the technology through very efficient R&D. And we've come through that phase now where we are now operating our spacecraft in space, and we're showing results from those operations. And so our core technologies have now been demonstrated to work in space. The growth phase now that we've really got to hit is to build our customer base, to start winning more competitions on the basis of that. And I think that's what I'd like folks to see is we think we've got a period of growth ahead of us that we can take advantage of, and that the technology we can continue to build on what we've done so far. And we've got a number of other things that we think are going to give us a competitive edge in this marketplace.
Absolutely. Well, thank you so much for this fascinating presentation. We would love to have you on in the near future with some of these updates.
Okay, thanks. Great being with you.
All right, everyone, stay with us. We're going to take a quick break for lunch, but stay logged in. We'll come back at 1:10 for Sidus Space. If for any reason you don't see us, just refresh your page. So we'll be back at 1:10 Eastern. See you soon.